In the heart of the Emmental region in Switzerland, the Berger Bell Foundry GmbH has been crafting traditional Swiss cowbells for over 290 years. This family-run business, passed down through generations, is one of the few remaining foundries that still produces bells using age-old methods. Each bell is not just a tool for tracking livestock, it is a piece of Swiss heritage, made entirely by hand with precision, care, and craftsmanship. The process begins with the creation of a mold. Using a special sand mixture, artisans shape the outer and inner forms of the bell. This step is crucial, as it determines the bell's size, shape, and ultimately, its sound. The molds are then dried and prepared for casting. Bronze, an alloy of copper and tin, is melted in a furnace at over 1,000 degrees Celsius. Once the metal reaches the right temperature, it is carefully poured into the molds. This stage requires great skill and timing, as the molten metal must fill the mold evenly to prevent imperfections. After the metal cools and hardens, the mold is broken open to reveal the raw bell. The raw bell is then cleaned, polished, and tuned. Tuning is especially important, as each cowbell must produce a clear and resonant tone. This is done by adjusting the shape and thickness of the bell, often by hand, for a perfect sound. Once tuning is complete, each bell is often engraved or decorated with traditional patterns. Many are paired with hand-stitched leather straps, adding to their beauty and authenticity. These final touches transform each bell into a unique and valuable object. Today, Berger cowbells are not only used on farms but are also treasured as gifts, souvenirs, and symbols of Swiss culture. The process of making them, showcased in a captivating short film, reflects a deep respect for tradition, quality, and craftsmanship that has endured for centuries. The process of transforming a straight steel pipe into a precise, durable bend involves a series of critical steps, each contributing to the structural integrity, dimensional accuracy, and quality of the final product. This transformation is essential in industries such as oil and gas, construction, and manufacturing, where customized pipe configurations are necessary to fit specific applications. The first and most crucial step in the bending process involves the use of an induction bending machine. This specialized equipment applies a high-frequency induction coil to heat a narrow section of the pipe. As the pipe is slowly pushed through the coil, the metal becomes pliable due to the intense localized heat, typically between 800 degrees Celsius and 1,000 degrees Celsius. Simultaneously, a bending arm applies pressure to shape the heated section into the desired radius. Once the pipe exits the coil, it is rapidly cooled with water or air, solidifying the bend in place. This method allows for precise control over the angle and curvature while minimizing wall thinning or deformation. After the induction bending is complete, the next step is cutting the bend to the required length. This step involves trimming the ends of the bent pipe to match specific design parameters or to remove any uneven or excess material resulting from the bending process. Precision cutting tools such as band saws or flame cutters are used to ensure a clean and accurate cut. This prepares the pipe for subsequent testing and further fabrication if necessary. Setting ovality of bend involves correcting any distortion in the pipe's roundness that occurs during bending. Ovality is the difference between the maximum and minimum diameters of the pipe's cross-section. Excessive ovality can lead to fitting issues, reduced flow efficiency, or structural weaknesses. To correct this, hydraulic presses, or specialized clamps, are used to reshape the pipe back to its intended circular form. This step ensures the bend meets required tolerances and maintains consistent wall thickness and internal diameter for proper functionality. Dimension check table is a critical quality control stage where the physical attributes of the bent pipe are thoroughly measured to ensure compliance with design specifications. The bend is placed on a dimension check table, an engineered platform equipped with precise measuring instruments such as calipers, height gauges, templates, and sometimes 3D scanners. Key dimensions verified include bend radius, angle, pipe diameter, wall thickness, straight length sections, and overall alignment. Technicians compare these measurements against the approved technical drawings or client specifications. Any deviations beyond acceptable tolerance limits are documented for correction or rejection. This step ensures the pipe bend will fit properly in its intended installation and function reliably under operational stresses, thereby maintaining the structural integrity and performance of the entire piping system. To relieve residual stresses induced by bending and to restore the mechanical properties of the steel, the pipe bend often undergoes a heat treatment process. Depending on the type of steel and the required properties, processes such as normalizing, annealing, or quenching and tempering may be applied. A destructive test is sometimes performed on a sample bend to assess its mechanical and structural integrity. This test involves cutting the bend to extract specimens for tensile, impact, and bend testing. The magnetic particle inspection (MPI) is a non-destructive test method used to detect surface and slightly subsurface defects such as cracks or porosity. The bend is magnetized using a yoke or coil, and a magnetic particle solution is applied to the surface. Any discontinuity in the material causes a disruption in the magnetic field which attracts the particles and makes the defect visible. This test is particularly effective in identifying flaws that could compromise the safety and longevity of the bend in service. Finally, the bend undergoes ultrasonic testing (UT), another non-destructive evaluation method that uses high-frequency sound waves to detect internal flaws. An ultrasonic probe emits sound waves into the pipe, and any reflection from internal defects such as voids, cracks, or inclusions is recorded and analyzed. This test ensures the internal structure of the pipe is free from hidden anomalies that could lead to future failure, especially in critical applications. Franchini Acciai S.p.A. operates a sophisticated forging facility equipped with 10 high-performance furnaces ranging in volume from 20 to 450 cubic meters, with dimensions up to 4 meters in height and 16 meters in length. These furnaces are designed to handle ingots and forged parts with capacities of up to 250 tons, providing the flexibility needed for a wide range of forging applications. Their varying sizes allow for the precise and efficient heating of components, whether sourced from in-house storage or delivered directly from steel mills via insulated trucks for hot charging. This setup ensures optimal thermal conditioning prior to forging, supporting consistent material properties and high throughput while minimizing thermal loss and processing delays in large-scale steel forging operations. Franchini Acciai S.p.A. operates 3 powerful open-die forging presses with capacities of 2,500, 3,500, and 8,000 tons, each equipped with automated manipulators for precise handling. These presses enable the production of complex forged components with final weights of up to 100 tons, ensuring exceptional forming accuracy, material integrity, and flexibility for diverse industrial applications. Franchini Acciai's heat treatment facility features 8 advanced furnaces capable of reaching temperatures up to 1,150 degrees Celsius, 2,100 degrees Fahrenheit, ensuring optimal thermal processing of large forged parts. 4 quenching tanks, using water or polymer, are supported by a semi-automatic loading system, enabling efficient, controlled, and uniform heat treatment for enhanced material properties. The quenching tanks at Franchini Acciai are engineered for effective stirring of the quenching liquid, either water or polymer, using adjustable speed propellers. This controlled agitation ensures uniform cooling, critical for achieving consistent mechanical properties. The system accommodates forged parts up to 24 meters in length, enabling treatment of exceptionally large components. Franchini Acciai's machining department is equipped with 4 vertical lathes and 9 horizontal lathes for precision turning of large forged components. Complementing these are 4 advanced milling machines enabling complex surface machining and detailed finishing. This setup ensures high-accuracy processing for components with demanding dimensional and geometric requirements. Franchini Acciai S.p.A., founded in 1968, is a leading European manufacturer of high-quality steel forgings. Headquartered in Mairano in the province of Brescia, approximately 80 kilometers from Milan, the company has built a strong reputation through decades of technological development, product diversification, and a steadfast commitment to quality and innovation. Operating in a highly specialized industry, Franchini Acciai produces open-die forged components used in some of the world's most demanding sectors, including oil and gas, power generation, naval, nuclear, petrochemical, mining, cement, and general engineering. With over 80% of its products exported globally, the company is an essential player in the international steel forging market. The company maintains a rigorous quality assurance system certified to ISO 9001 to 2015 standards. Quality control spans the entire production cycle, from raw material inspection to final product verification. Non-destructive testing methods such as ultrasonic inspection, magnetic particle testing, and dye penetrant analysis are employed alongside dimensional checks using gauges and templates. Mechanical and chemical properties are verified in-house with tensile and impact testing machines, microscopes, and spectrometers. The production process begins with a magnet lifter, which safely lifts and transports heavy steel plates to the next stage. Next, the edge milling machine precisely machines both edges of the steel plate. This ensures a uniform bevel angle and smooth surface, which are critical for achieving high-quality welds later in the process. The pre-bender introduces an initial curvature to the flat steel plate. This step reduces the required forming force and aids in achieving a more accurate final pipe shape, laying the groundwork for the JCO press. The infeeder accurately positions the pre-bent plate into the main JCO press. It ensures seamless material transition and maintains precise alignment for high-quality pressing operations. At the heart of the line, the JCO press bending machine gradually bends the plate in a JCO sequence to form a circular pipe. This staged approach minimizes material stress and enhances shape consistency. The Model 41114 is designed for high-strength materials in large diameters, making it suitable for heavy-duty applications. Once the pipe is formed, the turning transfer car rotates and moves the pipe to subsequent stations. It ensures gentle handling and efficient transfer without damaging the pipe structure. The tack welding machine applies temporary welds to hold the pipe edges in place. This step is essential to maintain alignment before full internal and external welding occurs. The inside welding machine performs complete internal welding using automated torch systems. It delivers consistent, high-penetration welds that ensure structural integrity. Post-inside welding, the back bead cutting machine removes excess weld material, beads, from the inside to smoothen the surface and prevent internal flow restrictions in applications like oil or gas pipelines. The outside welding machine performs the final external weld along the pipe's longitudinal seam using automated, high-precision welding heads. It employs advanced techniques such as submerged arc welding, S.p.A, to ensure deep penetration, minimal spatter, and excellent weld uniformity. This results in a robust, smooth, and aesthetically clean seam that meets stringent structural and quality standards. The four-way machine, in pending machine, applies calibrated mechanical pressure from 4 directions, top, bottom, and both sides, to correct ovality and dimensional deviations caused during forming and welding. It restores the pipe to a true circular shape, ensuring tight tolerance control. This step is critical for pipes intended for high-pressure applications, where precise roundness and uniform wall thickness are essential. The end-facing machine trims and bevels the pipe ends, preparing them for further joining or installation. It ensures that the pipe ends are perfectly perpendicular to the axis and ready for welding or flanging. The washing device thoroughly cleans the pipe interior and exterior. Finally, the X-ray test machine conducts non-destructive testing of the weld seams. At Amazon, the production of seamless steel pipes follows a meticulous, high-precision process conducted at our advanced facility in the Edirne Organized Industrial Zone. Spanning 15,000 square meters outdoors and 8,000 square meters indoors, our plant specializes in manufacturing seamless pipes with wall thicknesses ranging from 5 to 15 millimeters, along with self-drilling bolts, an innovative variant used widely in geotechnical applications. The process begins with the careful selection of high-quality alloy steel, meeting international standards. Each batch of raw material is rigorously tested for quality to ensure consistency and reliability in the final product. Steel billets are then heated until they reach a soft, malleable, gum-like consistency. This critical stage enables the material to undergo significant physical transformation without cracking or compromising structural integrity. Once properly heated, the billets are pierced without any chip removal, a defining characteristic of seamless pipe production. This is followed by drawing operations in the first and second pipe drawing units. In these units, the material undergoes a series of controlled heating and cooling cycles to retain its molecular structure while being reshaped into the desired pipe form. These thermal treatments enhance the mechanical properties and ensure uniformity. All external treatments, including threading, are performed using hot processing methods, which further improve the durability and performance of the pipes. The seamless nature of the product ensures superior strength, resistance to pressure, and a smooth internal surface, free from weld seams. In addition to standard seamless pipes, Armosan also produces self-drilling bolts, referred to internationally as self-drilling anchor bolts, used extensively in tunneling, mining, and unstable soil conditions. These bolts allow drilling, installation, and grouting to be performed in a single operation, increasing efficiency on job sites. Through continuous innovation, strict quality control, and the use of advanced hot forming techniques, Armosan delivers seamless steel pipes and bolt systems that meet the highest global standards for industrial and geotechnical applications. When it comes to handling heavy concrete pipes on construction and infrastructure projects, safety, efficiency, and precision are non-negotiable. The Nimatec pipe lifter is designed specifically to meet these demands, offering a modern and highly effective solution for lifting and installing DN1250 concrete sewer pipes, weighing up to 3,600 kilograms. Intelligent design without hydraulics. One of the most distinctive features of the Nimatec pipe lifter is its non-hydraulic operation. Unlike traditional pipe handling systems that rely on hydraulic components, the pipe lifter functions mechanically, making it more robust and less prone to breakdowns. This simplifies maintenance and improves reliability on site. It also reduces the risk of hydraulic fluid leaks, which is an important environmental and safety consideration on many job sites. The pipe lifter is attached to an excavator or other lifting equipment via a quick coupler, allowing for fast and easy connection and disconnection. This compatibility with standard equipment ensures it fits seamlessly into most existing fleets without the need for custom adaptations. Secure and direct pipe handling. The system grips the pipe at its end face, capsicant, which is a key advantage in operational efficiency. This method of gripping allows operators to push the pipe directly into position, streamlining the installation process and reducing the need for manual adjustments. Because the clamp holds the pipe securely and evenly, the risk of slippage or damage is minimized, which improves safety and preserves the structural integrity of the pipes. With DN1250 concrete pipes, weighing up to 3,600 kilograms, secure handling is essential. The pipe lifter's design ensures that even large and heavy pipes can be maneuvered with ease and precision. Angled lifting for obstacle navigation. Another major advantage of the Nimatec pipe lifter is its ability to hold the pipe at a 25 cranrame angle during transport and installation. This angled position offers several practical benefits. It allows operators to navigate around obstacles, such as trenches, barriers, or uneven terrain, without the need for excessive repositioning. It enhances visibility and control during placement, enabling more accurate alignment with existing pipes or structural elements. It promotes stability during movement, reducing the chance of swinging or unintentional rotation, which are common safety hazards when handling large objects. This thoughtful design contributes significantly to both job site efficiency and worker safety. A tool for the modern job site, the Nimatec pipe lifter represents a leap forward in pipe handling technology. Its non-hydraulic design, quick coupling system, and angled lifting capability make it particularly suited for modern sewer and infrastructure projects, where time, safety, and precision matter. Contractors using the pipe lifter benefit from reduced labor demands, faster installation times, and fewer safety incidents. Whether used on urban sewer systems, industrial drainage projects, or large-scale civil engineering works, the pipe lifter proves to be a reliable partner for any project involving large concrete pipes.